Hi, this is Alex from devstories.eu. PyCharm, Dedicated Python IDE, Episode 3 of 5. If your code is littered with print statements just to see what a variable equals, you are wasting hours of development time. It is time to stop guessing and start observing. Today, we cover mastering the debugger, state, and breakpoints. Think about tracking down a bug in a data transformation script where a dictionary value is mysteriously becoming none. If you use print statements, you have to write the print, run the script, read the console, realize you printed the wrong thing, and start over. The debugger replaces this loop entirely. It allows you to pause the execution of your program, inspect the memory heap, check variable values, and examine thread states without ever modifying your source code. To start, you set a line breakpoint. You do this by clicking in the left gutter of your editor, next to the line number where you suspect the issue begins. A red dot appears. Next, you launch your script into bug mode by clicking the bug icon instead of the standard run button. Your program executes normally until it reaches your breakpoint. Execution suspends immediately before that marked line of code runs. When the program suspends, the debug tool window opens automatically. Here is the key insight. The variables pane inside this window gives you a live, interactive map of your application state. You will see every variable currently in scope. You can expand your dictionary to see all its keys and values at that exact microsecond. You also have access to the Evaluate Expression tool. This allows you to run arbitrary Python code mid-execution. If you want to run a quick list comprehension on your data or check a complex condition, you type it into the evaluator. It processes using the current application state and returns the result. You can even use this tool to overwrite a variable value on the fly, testing a potential fix right there without restarting the debug session. You can also look at the frames pane, which represents your call stack. It shows the exact sequence of function calls that led to your current breakpoint. Selecting a different frame lets you inspect the local variables of the functions that called your current code. Once paused, you need to advance the execution line by line to isolate when the dictionary value turns to none. This is called stepping. Developers often confuse stepping over with stepping into. Step over means executing the current line and pausing at the next line in the current file. If the current line contains a function call, step over runs that entire function in the background and drops you at the next line in your active file. You use this when you trust the function works correctly. Step into means diving inside the function call. The debugger moves execution to the first line of that newly called function, letting you trace its internal logic line by line. By using breakpoints and stepping, you control the flow. You pause just before the suspected error, step into the transformation function, and watch the variables pane update. The exact line that executes right before the dictionary value becomes none is the source of your bug. The debugger is not just a tool for finding crashes. It's an interactive lens that gives you absolute authority over your program flow and memory state. That is all for this one. Thanks for listening and keep building.